channel. Today we're going to work on the question find all numbers disappeared in an array. This is an easy level array question. The question states given an array of nums of n integers where nums I is in the range of 1 to n, return an array of all the integers in the range 1 to n that do not appear in nums. Let's look at their example. So nums equals 4, 3, 2, 7, 8, 2, 3, 1. You can see there's like duplicate 2's. And output is 5 and 6 because let's count how many indexes there are. 1, 2, 3, 4, 5, 6, 7, 8. So then it should include from 1 to 8. And in this one, there's duplicate 2's and duplicate 3's. And what's missing is 5 and 6. So 1, 2, 3, 4, and then 5 is here, 6, 7, 8. And for this one, the length of the nums is 2, so it should, the ideal output should be 1 and 2, except it has 2 1s, so what's missing is 2. I hope that was clear. So thinking of this like a really simple brute force solution, maybe not brute force, but just a simple solution using Python would be using the set difference. So we can create like nums2 equals what we want in the result, which is a list of range from 1 to length of nums plus 1. Actually not a list, a set. Because we're using the set difference and we want to make sure there's no duplicates when we find the difference. So in the end we can just return nums2 minus the set of nums. So yeah, this is a simple way to solve this, but this is not the ideal way. The ideal way they want us to solve, could you do it without extra space in the O and runtime? You may assume the return list does not count as extra space. And also looking at its constraints, n equals nums length, 1 is smaller than n is smaller than this. So from this question we know that we assume all integers are positive, and with this assumption we can take advantage of solving this in O1 time space, because we can use negative markers. So basically all of our list is going to be positive. It might have duplicates, so whenever we visit a number in the list, let's say 4, we want to mark the actual index of it, the correct index, which is index 3. Ideally we start from 1, 2, 3, 4. So it would be 0, 1, 2, 3, index 3 as a negative, like the 7 we would turn to a negative 7. So we mark this one as visited, and then I'll show you when I write this in code, it's easier. So for I in range of length of nums, we can do like the correct index of each value in this list. We want to work on the original nums list because we don't want to generate a new list. The correct index would be the nums I minus 1. So the value of nums I minus 1. So index 0, when we go here first, it will be 4 minus 1, which would be 3. 3 would be its correct index, and from there we can flip its correct index to negative. We are basically, the solution is using a negative marker, and then if it's already visited, we check if it's already visited by seeing if nums I is greater than, correct index is greater than 0. That means this is not visited. And then we flip it to a negative. So we do nums correct index times equals -1. We flip it to a negative. We mark it as visited by using a negative marker. And using this way, we don't need to create any extra new list to make it so we preserve the original numbers. We would need to use absolute, because this way we also get rid of, we solve the duplicate problem, because if it's already visited that correct index, for example, there's like a 2 here, and then when we reach this 2, that correct index for 2 will already be flipped to -1, so 0, 1, 2. This will already be flipped to -2, so we would not flip it again because it's the same thing. And here, for finding the correct index, we use absolute because just in the case of duplicates, or if we visit that number before, it would already be negative, and we're checking for the correct index, so we would use its positive number. And then in the end, we can create a result list, and then we go through the nums list again. And we don't go through the nums list, sorry, we go through what we want as the result. So what we want is, like, for example, the length of nums. So for example, this one has 1 to 8, right? So we want 1, 2, 3, 4, 5, 6, 7, 8. So we'll use that as our correct. For I in range from 1 to length of nums plus 1. So basically we check if it's just, we check if each number in that list is a negative. If it's a positive, it means it's not in this list. So basically, if nums I minus 1 is greater than 0, then we know it is not present in the original nums list because it hasn't been visited. So that's when we add it to our result. Result got a 10 I, and in the end we just return result. Yeah, so using the solution, the time complexity would be O(n). We go through, use the list ones, and then the space would be O of 1 because everything is done on the original nums list. It's in place modification basically with negative markers. You can think of this like, normal DFS matrix questions where when you visit a spot in the matrix or path, you mark it as -1. The difference is with this question, you flip the original array number to times -1, so you flip it to a negative number, assuming everything in this question is positive because it's from 1 to n. Then when it's flipped to negative, you also preserve the original number because when we use it, we use the absolute. We preserve the original number, we also have we know which numbers are present by flipping the correct index to a negative, marking as visit. So whatever is left that's positive means that's the numbers that we're missing. So I hope that was a good explanation. Sorry, I'm a bit bad at explaining this solution. So let me know if you have any questions. I would love to answer them. Thank you so much for watching and have a nice day.